Dear learners, I am Dr. Rajamani, Assistant Professor, Department of Chemistry, the Standard Firehouse Rajaratnam College for Women, Sivahasi. In this video, I am going to explain about some basic insights about molecular spectroscopy. Particularly, my topic is going to cover the interaction of molecules with radiations. In this video, we are going to learn what's the meaning of spectroscopy and how the light actually interact with our molecules. If you know the answer for these two questions, then automatically we can understand what is a spectroscopy and how we can interpret the spectrum of different molecules. First, we can see what is a spectroscopy. It is a study of how matter interacts with the different wavelengths of light. This picture explains the different regions of electromagnetic radiations. It starts from radio wave to gamma rays. And the regions which cover the ultraviolet, vibrate, visible, infrared, microwave, they come under the category of molecular regions. We have to understand this molecular region very carefully so that we can explain what are the molecular processes happening within this region. In the ultraviolet region, electronic transitions are possible, and in the infrared region, vibrational transitions are possible, and in the microwave region, the rotational transitions are possible. These are the regions which explain what kind of molecular processes are happen when the molecules interact with our electromagnetic radiations. If we understand this molecular process carefully, then we can apply them to different applications. First, we can start with the light. Light is nothing but electromagnetic radiations. It is a combination of electric as well as magnetic field. If you make the light to interact with the matter, certain kind of processes are possible. That is, the light can undergo reflection through the matter, or it can undergo transmission, or it can undergo scattering or photoluminescence. Many such phenomena are possible. If you understand the interaction of light with our molecule, then automatically we can able to understand what kind of spectroscopy we can study using this light. Radiations are mainly made up of electric as well as magnetic field. When the molecules undergo interaction with this electromagnetic radiations, then only molecular spectroscopy field is possible. So, the molecular spectroscopy is nothing but the study of interaction of your molecules with the electromagnetic radiations at different wavelengths. Before studying the interaction of our electromagnetic radiations with molecules, now let us see something about the photons. Light, that is electromagnetic radiations, they exhibit both the wave and the particle nature. When light interacts with the matter, it means the package of energy called photons, they are going to interact with our molecules. The amount of energy possessed by the photons are given by the Planck's equation and is represented as E is equal to h nu. The frequency is related to wavelength by the expression nu is equal to c by lambda. Now the Planck's equation now changed as h c by lambda. But generally in spectroscopy, particularly in the case of vibrational as well as rotational spectroscopy, the wavelength is often represented in wave number. Though a lot of molecular processes are possible when interacting with the radiations, few phenomena are very important. The first thing is absorption. Already we know about absorption. So when you consider a molecule going to be present in the ground state, and if some of the photons going to interact with the molecules present in the ground state, the molecules will be able to transfer to the excited state. This is called as the absorption. And the second case is the emission process. The molecule which is going to be present in the excited state, after staying at the particular excited state, it tries to come back to its original state, that is a ground state. This come back to the original ground state is possible by the emission of certain amount of energy, and this process is called as the emission. And other than absorption and emission, some other process is also very important, that is a scattering process. When the incident photon is going and hit the molecules, there are two types of scattering is possible. One is with no energy change, another one is with energy change. The incident photon come out of the molecule without change in the energy. In this case, the incident photon as well as a scattered photon, they have the same energy level. But sometimes when the incident photon, after hitting the molecule, when it come out of the molecule, it has some energy changes. Sometimes it will lose its energy, sometimes it will gain energy. This is also play a very important role in understanding the molecular spectroscopy. Now we can state what are the different molecular energy levels available. These molecular energy levels are picturized as a function of internuclear separation and molecular energy. And one thing we have to carefully note down, that if there is a possibility of interaction with the molecules, then only this molecular energy levels are possible. So we have to make the electromagnetic radiation to interact with the molecules, and we have to find out the outcoming radiations, and we have to analyze the outcoming radiations. From the output of the outcoming electromagnetic radiations, only we can find out what are the different phenomena occur in your molecules. Based on this, we can tell which molecular spectroscopy we can apply for the particular molecules. So this is a molecular energy level diagram, and this diagram consists of three different energy levels. It shows the three different molecular energy levels. The bottom line picture represents the ground state of the electronic transition state, and the upper portion explains the electronic excited state. The parallel lines which are present within the electronic state are called as the vibrational energy states, and the parallel lines which are lying within the vibrational energy levels are called as the rotational energy levels. When you make the electromagnetic radiations, that is, if you use the radiations which are available in the UV region to interact with the molecule, then the transition will be happen from the ground electronic, that is electronic ground state, to the electronic excited state. And if you are using the far red region, far red or infrared region, in this case the transitions will be happen within the vibrational energy levels, because the infrared region radiations are having the energy which is not sufficient to carry out the electronic transition. And if you carry out the interaction of molecules with the microwave radiations, in this case the transition will happen between the rotational energy levels. this energy is not sufficient to carry out the vibrational energy transitions. So if you are using UV radiations, then automatically transition will happen between the electronic transitions, and if you are using infrared regions, then the transition will be happen within the vibrational energy levels, and if you are using microwave radiations, automatically rotational energy transitions will be possible. With that, I have explained all the basic ideas about molecular spectroscopy. Thank you for watching this.